Hello, this is a description of our approach to managing simultaneous multi-party conversations. This is work that I've done with my colleagues Diego Gossamer, Emmett Coyne, and David Atwater at the Linux Foundation AI and Data Foundation Open Voice Interoperability Initiative. What we're going to be talking about is how do you have a multi-agent interoperable system where the agents are all present at the same time and can listen to and react to what the other agents are saying. Our approach is based on communication among the agents using NLP APIs, so we don't have to depend on, for example, the agents having an understanding of a common intent and slot structure. We have some structured metadata, but the main communication among the agents is via natural language utterances. We have an important goal of maintaining compatibility, interoperability among agents, and we do that with some standard protocols. This is a scalable and technology-agnostic multi-agent architecture, and one feature is that because it's technology-agnostic, it's also backward compatible with traditional NLP systems. Although we expect just for the system to understand natural language, which can be based on an LLM or a more traditional natural language technology. There are no constraints on different AI models or frameworks, or what frameworks could be used. And we believe this is efficient and secure because it enforces structured agent participation. So here's an example of a multi-agent conversation that might take place with our framework. We have a couple of important concepts. One is the convener that invites the assistants to a task and gets them up to date on what the users wanted. We have 4 assistants here in this example, and also a conversational floor, which is really the mechanical part of making sure that all the agents can talk to each other and hear each other. So we start with the user making a request for help with travel planning. This involves a flight assistant that knows about flights, which pipes up and says, here are some flights. Then a hotel assistant that pipes up and says, here's some hotel recommendations for those dates. The rental car assistant has some information about cars. And finally, the Philadelphia activities assistant, which has been listening to all of the other assistants and points out that if you stay another day, there's a concert you might like. So because this agent has been listening to the conversation, it can help the user change their dates before they've committed to some flight and hotel recommendations, which you would have to do in a traditional travel planning pipeline. To sum up, our key concepts and contributions are the convener agent, which manages agent invitations and turn-taking, the conversational space or the floor, and the floor manager that handle providing the basic conversation environment that enables multiple agents to collaborate in real time, and it handles potential problems like interruptions and uninvited agents.